Hello friends, welcome to Exam Tricks. This video is part of the series covering Unit 4 Climate and it deals with Chapter 9 Solar Radiation, Heat Balance and Temperature. This chapter will be divided into two videos. First part will cover solar insolation and the factors responsible for the variation in solar insolation received by the Earth and the atmosphere. We know that Earth receives almost all of its energy from the Sun. However, this energy varies at two levels. First, energy received at the top of the atmosphere, and second, energy received at the Earth's surface. We will learn about the factors in both of the cases. Energy received at top of the atmosphere varies because of two reasons. First, because of the spherical shape of the Earth, the sun's rays fall obliquely on the atmosphere and it very small portion of the sun's energy received by the atmosphere. Second factor is the distance from the sun. We know that Earth revolves around the sun in an elliptical orbit, which means that at 2 points Earth is at one point Earth is farthest from the sun and at one point Earth is nearest to the sun. On 4th of July, Earth is farthest from the sun and it is called ephelion, while on 3rd of January, the Earth is nearest to the sun and it is called perihelion. However, the other factors like the distribution of land and sea, atmospheric circulation mask the effect of these factors. Energy received by the Earth's surface varies because of the following reason. First, the rotation of Earth on its axis. Second, the angle of inclination of the sun's rays. Third, the length of the day. Fourth, the transparency of the atmosphere. Fifth, the configuration of land in terms of its aspect. Among these reasons, the first two reasons, the rotation of Earth on its axis and the angle of inclination of the sun's rays, are the most important one, and we will try to understand both of these in detail. The Earth's axis make an angle of 66.5 degrees with the plane of its orbit round the sun, which means that different latitudes, different amount of insolation is received throughout the year. This causes solstice and equinox. In the month of June 22nd and 23rd, summer solstice occur in the northern hemisphere, which receives maximum insolation during this time, while winter solstice occur in the month of December 21st or 22nd day in the southern hemisphere when it receives maximum insolation. However, there are 2 points in the year when both the hemisphere receive equal insolation and it is called equinox. In the month of March, there is vernal equinox when both the hemisphere receive equal insolation, while in the month of September, autumnal equinox occur. The second factor, angle of inclination, also influence the insolation. Higher the latitude, less is the angle that they make with the surface of the Earth, and second, the slant rays cover more area and therefore net solar radiation decreases. And when they travel more area, they travel through greater depth of the atmosphere, much of the energy is absorbed, scattered or reflected back. This is the reason that the tropical region receives maximum insolation while polar regions receives less insolation. Third factor is the passage of solar radiation through the atmosphere. We know that higher the frequency, shorter the wavelength, and the short wavelength easily passes through atmosphere. Within the troposphere, there is ozone layer, water vapor, gases which absorb much of the infrared radiation. Small suspended particles scatter visible spectrum both to the space as well as towards the Earth's surface. This scattering also adds color to the sky. Finally, the spatial distribution of insolation at the Earth's surface. Maximum insolation is received over the subtropical desert, where the cloudiness is the least, because most of the clouds reflect back the insolation, and since in the subtropical deserts there is least cloudiness, so maximum insolation is received. Equator receives comparatively less insolation than the tropics. Generally, at the same latitude, the insolation is more over the continent than over the ocean. And finally, in winter, the middle and higher latitudes receive less radiation than in summer. This completes our first part of the video. In second part, we will discuss heating and cooling of atmosphere, heat budget, and the concept of temperature inversion. Thanks for watching. Comment below if you want to have any discussion or query, or have any feedback for us. Subscribe to the channel. Thank you.